I have question 2, which can be read, which just gives you an equation. So it says, if 9 raised to the power of 2 minus x equals 3, find x. So it's saying, what is x? You have an equation, and then you have a number raised to a power. So automatically your minds are all going down to the laws of indices, which you should have learned, or which you need to know to solve this question. For this question, the useful laws would be, I'm telling you beforehand because I'm going to use them in the solution, so because you expected to know this to solve the question. Follow it. X to the n, if x to the n is equal to x to the m, n equals m. So if you have an equation where you have on the left hand side a number raised to some power, and on the right hand side you have a number raised to another power, let's say, and everything, let's say you knew the number. So the number is x, you know x is the same as x, but n and m you don't know. You know that they must be equal to each other. So say 2 to the 2 must be equal to 2 to the 2, because they're the same. 2 to the 2 cannot be equal to 2 to the 3, because 2 to the 2 is 2 times 2. 2 to the 3 is 2 times 2 times 2. That's a different number. So for 2, so if I said 2 to the 2 equals 2 to the n, you automatically know that since the bases are the same, I can equate the powers, the indices, that's what they're called. So n equal to 2. It must be. Otherwise, they wouldn't be equal to each other. The left-hand side wouldn't be equal to the right-hand side. I think that's one of the useful laws for this question. Another one would be the law of indices, which goes as follows. You have a variable or number. So variable takes any number. So I just call it variable raised to the n, raised to the m. So a variable raised to a number raised to another number, or raised to another number, is the same thing as saying that number raised to the n times m. So as an example, 2 to the 3 all raised to the 4 is 2 to the 3 times 4, which is 2 to the 4 times 3 is 12. So you need to be familiar with these two laws of indices, this law and this law of indices. Well, this isn't really a law of indices, but it's something you can deduce. This is a law of indices. Or forget the fact that they're laws. These are just rules in mathematics that you need to know. So let's go to solving the actual question using these laws. Let me just keep you on the screen so you can scroll back. Okay. So we have 9 to 2. Okay. Yeah. So 3 is 3 to the 1. Now, the way to solve this problem is to look at this and you see 9 and you say, okay, x is a power and we have a power here. What if I could rewrite this side? So we had a base of 3, so that I could then equate the powers and have an equation in terms of x, which I'll then solve to find x. What if I could do that? Well, you can. So if I said I want 9, I want to know what 9 is when it's in terms of 3 raised to some power. How do I determine that? I already know that, I mean, intuitively. Maybe some of you obviously did already know that 9 is 3 to the 2, but some people may not know. And one way to do this is just say, okay, 3 times itself, how many times gives 9? So let's say 3 times 3. Well, that's 9. So we're lucky. So that means that's 3. This is the same thing as 3 to the 2 because you're multiplying 3 by itself. 3 times 3. So yeah, there are 2 3's involved. That's what 3 to the 2 means. 3 twice, 3 by itself. Anyway, so that means 9 is 3 to the 2. But in the question, we're given 9 to the 2 minus x. That means 9 to the 2 minus x is equal to 3 to the 2 to the 2 minus x. So we're now going to use the law of indices. I'll rewrite it. X to the n to the m is x to the n times m. So that's the same law we're going to use for this expression. Oh, hold on. We're going to use it, but now the equation, we've written the right hand side, which was originally 9 to the 2 minus x, as this. The right hand side we haven't changed, that's still 3, and 3 is the same thing as 3 to the 1. You know that any number raised to the 1 is itself. So you need to know this. You need to know that, obviously. So now, let's use this law. Some people can do it in their heads, but for those who can't, I'll just break it down. So if you compare this expression, the idea is, so we have just one number raised to another number, which is the same format as here, a base raised to a power, so then you can equate the powers. That's the objective. It will become clear as soon as I do it. So if you compare this side to this side, because this side, this number here, or this expression here is in this form, we want to take it to this form. And this is the way to do it. So x is 3. If you compare, x, 3 is the base. N is 2, as you can see, in the same position. And m is the number you multiply outside, or the expression, which is 2 minus x. Therefore, using this form, it says you can say that 3 to the 2 to 2 minus x is equal to x, which is 3, raised to the n, which is 2, by m, which is 2 minus x, which is 3 to the, so let's simplify this. 2 times 2 minus x is 2 times 2, which is 4. Then you keep the minus sign. That's a minus sign, sorry about that. And then 2 times x, 2x. So the left hand side now, the original expression is 3 to the 4 minus 2x. Remember, we haven't touched the right hand side, so that still stands. But we've just rewritten the right hand side in a form where we have the same base so that we can equate the powers. Now we have the same base, we can equate the powers. Equating the powers. Gives 4, so the powers, 4 minus 2x equals to 1. So now all we have to do is make x the subject of the formula. So that just means isolate, or that's the way I do it, I isolate x on the left hand side. So I gradually carry out mathematical operations like addition, subtraction, multiplication, and division, so that eventually I'll just have x on its own on the right hand side. I have something of the form x equals, whatever, and this will be the value of x. So from here, let's get rid of the 4 on the left hand side, so that we just have minus 2x left. So we're getting closer to having only x. So how do I do that? I'll subtract 4 from both sides. So 4 minus 2x minus 4 equals 1 minus 4. I can rewrite this as this, 4 minus 4, just bring this there, 4 minus 4 minus 2x, same thing, equals 1 minus 4. Now obviously 4 minus 4 is 0, so that disappears. We have minus 2x equals 1 minus 4 is minus 3. So now just to get x on its own, I can divide both sides, i.e. both the left hand side and right hand side, by minus 2. Because once I do that, I get rid of the minus 2 on the left hand side, and then I have just x. Why do we have to do the same thing to the left hand side and right hand side? Because what you have in an equation is the statement a left hand side is equal to the right hand side. So if I do something to the right hand side, say I divide the left hand side by 2, the equality doesn't hold anymore, unless, because originally they're equal, like L left hand side is equal to right hand side. So I can basically write the right hand side as the left hand side, because they're equal. Now that I've divided the left hand side by 2, they're no longer equal, unless of course I do the same thing. So you just have to do the same thing to both sides. Anyway, dividing both sides by minus 2 gives the following. And my pen is failing me. Oh, see. Gives minus 2x by minus 2 equals minus 3 over minus 2. Minus 2 divided by minus 2. Oh, minus 2 and minus 2 is 1. So I carry the division. Gives x. Here the minuses cancel out, so you're left with 3/2, and that's your solution. Hope that made sense. If it doesn't, ask any questions in the comments. Thanks.